So welcome back to the Flipped Classroom. I'm Mr. Gill, and today we're looking at lesson 8.2 from Math Links 9. And this is our second lesson in solving equations. So a couple of cartoons. I think we saw this one last time. Algebra is weightlifting for the brain. So always remember when we're doing this sort of work that this is really good in improving our brain power and it's building skills. The other thing here is, oh, look at our little student mathematician, just a darn minute. Yesterday you said that x was equal to 2. So remember, x is a variable, and because it's a variable, x can take on many different values depending on the equation. So let's go have a look at this first thing here. Now this is not on your in your notes package. I want you to think about this. I want you to think of a number. Choose a number between 1 and 10. Now, you can choose your own number. I'm going to think of a number here, randomly thinking here. I might choose a number 7. Now, it didn't have to be between 1 and 10. I just said that for convenience. Now, we're going to perform a series of operations here. So the first thing that I want to do here is I want to multiply my number by 3. So I'm going to have 3 times 7, and that gives me 21. Now, my next step here is to go through and I want to subtract 5. So 21, and I'm subtracting 5, and our resultant number here is we get 16. Now we did 2 different steps there, or 2 different operations. If the number had been called x, we did 3 times the number x first, and then we subtracted 5, didn't we? Now, if we went through and reversed the process, so I want you to think here, in my case, we finished up our resultant number here was 16. So if we start with that number, so starting with 16, is there any way that we can get back to the number that we started, which was 7? Now, of course, what we're going to do here is we're going to start with going through, we're going to reverse the order of the operations, and we're going to use the inverse of the 2 operations up here. So we're going to begin here by going through, the last thing we did was subtract 5, so we'll start by going through, the inverse operation is adding, and so we'll start with, first of all here, 16, and we'll add 5. Now that gives us 21. Then we'll go through, and the last thing we'll do is the inverse operation of multiplication is division, so we'll do 21, and we'll divide it by 3, and that takes us back to 7 again, like that, doesn't it? So I want you to think here. When we're solving equations, we're often going through and we're doing the inverse operation, and we're also reversing the order of the operations. So the original order was multiplication followed by subtraction. When we went backwards, we started with addition, and we followed it by division. So let's see how that works. That sort of principle works with solving equations. Now these are what we call 2-step equations. A little bit of quick practice here. These ones involve nice, easy numbers. So that's a good place to start. So we've got 2 times the number x plus 7 is equal to 15. Now the first thing that we're going to do here is we'll write the equation out again. We'll give ourselves a little bit of extra space for it. And I want to remove the addition by 7. So I'm going to start by subtracting 7 here like this. 2x is equal to, now what's 7 minus 7? 7 minus 7 is 0. 15 minus 7 is equal to 8. Now you've seen this. This is now we've got it down to a single step. Multiplication by 2. How do we go through and inverse that? If we divide by 2 here, divide by 2 over here, and of course you know what happens. The 2's cancel out there, and we're left with x is equal to 8 divided by 2, which is equal to 4. Now think about it. 2 times 4, if we substituted it back in there, 2 times 4 is 8, plus the 7 is equal to 15. Now, I want you to pause the tape here and go through and do B and C and see how you make up with those. So the second one here, I went through, I rewrote the equation again. I started with the subtraction. The inverse operation is addition. I added 30 to both sides. Now remember, equations, very important to keep them balanced up. What we do to one side, we must do to the other. So we added 30. Now minus 30 plus 30, of course, gives us 0. So effectively, what happens there is they just cancel out, don't they? And that leaves us with 5 times a is equal to 100. Then I did the division by 5, and I'm left with a single 1 times a on the left-hand side. 100 divided by 5, that's easy, that's equal to 20. Now, what have you got? 5 times 20 is 100, minus 30 is equal to 70. All right, have a look at the last one here. Watch out for those negatives. Remember your rules. So you can pause the tape. I'm going to go through and do it. Now, this time I didn't put I simply imagined in my head there I'm subtracting 10, subtracting 10. All right, so I'm left with minus 3y. So on the right hand side we've got minus 30 and we've got negative 3y. So here we need to go through, divide by negative 3, divide by negative 3. Y is equal to, now, two negatives, division. We're going to get a 30 divided by 3, and of course it stays as positive 10, doesn't it? And you can check it out there. Negative 3 times 10 is negative 30. Negative 30 then plus the 10 indeed is equal to the negative 20. Okay, so what's the principle that we've got at work here? To isolate the variable in a two-step equation, use the reverse order of the operations. Okay, add or subtract first, then multiply or divide. So our next example here is we've got two equations, and the only difference with what we've just done there is that these ones involve rational numbers. So let's begin with the first one here. So this is going to require us to remember a little bit of work about how we add and subtract fractions. So beginning off here, we've got 2x plus 1 over 10 is equal to 3 over 5. So what we need to do first of all in isolating the x, we're going to subtract 1 over 10 and subtract 1 over 10. And this is nice and easy. 1 over 10 minus 1 over 10 is 0, and we're left with 2x is equal to, now look at this here, 3/5 minus 1 over 10. We need the same denominator. Now think about this. 3/5 we can change into tenths. 5 and 10 are the denominators. The lowest common denominator will be 10 simply by multiplying by 2. So 6 over 10. So we've got 6 over 10 minus 1 over 10, and that's equal to 5 over 10, isn't it? Now, hey, 5 over 10, that's easy. 2x reducing the 5 over 10 is equal to 1/2. Now, what's the next thing that we have to do here? The next thing we have to do is divide both sides by 2. Now watch how I do this. I'm going to do my division like that on the left-hand side, dividing by 2, showing it like a fraction. On the right-hand side, one way I can do it, I can do my division by 2 in that format like that. Now, 1/2 divided by, and of course 2 is like having 2 over 1, isn't it? X is equal to, now, division with fractions. What do? What's the word for it? We flip and multiply. So we're going to change our division to multiplication by the, what do we call it? We flip it over, it becomes the reciprocal. So that becomes 1 over 2. And multiplication is easy. We multiply the tops. 1 times 1 is 1. 2 times 2 on the bottom, which is 4. And that's what we're left with there. X is equal to 1 over 4. So if you check that out there, 2 times 1 over 4 is 1/2 plus a tenth, and if you figure it out, that indeed is equal to 3/5 or 6/10. Okay, why don't we check this one here, this next one. Now, oh dear, look at the right-hand side there. We've got a mixed number there, don't we? Now, it's probably going to be easier to go through and rewrite that as an improper fraction. So, negative 1 3/4. Now, don't worry about the negative for the time being. 1 times 4 is 4, plus the 3 gives us 7 over 4. So 1 3/4 is the same as 7/4. and it's negative. So we'll start off here, x over 3 minus 1.5, and we'll write it as equal to negative 7 over 4. What do we need to do now? We need to, in isolating the x term, we need to go through. What are we going to do? We're going to add 1/2. Here we're going to add 1/2. Now, x over 3 is equal to negative 7 over 4. Now, we need the same denominator. Now, 1/2 is easy to turn into quarters, isn't it? So, mental math here, we'll simply add 2 over 4. Okay, and that was simply, we just simply multiplied the top and the bottom by 2, didn't we? X over 3 is equal to, now, when the denominators are the same, what do? All we need to do is go through and add the two numerators. Negative 7 plus 2, negative 5 over 4. So what's now? On the left-hand side, we've got x divided by 3. So doing the inverse of that, we're going to multiply by 3, multiply by 3. 3's cancel out. We're left with a single x is equal to, now think of this, it's like 3 over 1. Negative 5 times 3, negative 15. 4 times 1 is 4. Now that's an improper fraction, isn't it? We could leave it like that, or we could change it back into a mixed number again, because that's what the right-hand side was originally. Now, how do we do that? 4 divides into 15 how many times? 3 times. There's 3 remainder, so 3 3/4. And because the whole number was negative to start with, we have to put a negative sign there, don't we? So there's our solution there. Okay. Let's go and look at the next page here. Now, I want you to try these two here. You can pause the tape and go through and have a go at those. And I'll do the solutions as well. So this is what I get for the first one here. I went through. First of all, I subtracted negative 1/2 from both sides. Now, looking at the right-hand side was 3/4, so I changed my 1/2 to 2/4 to get the same denominator. So on the right-hand side, I've got 3/4 subtracting 2/4, which is 1/4. 2 times y is equal to 1/4. Then I divided by 2. Dividing by 2 is the same as multiplying by 1 over 2, and that's what I end up with there. 1 times 1, 4 times 2, so it's equal to 1/8. Right. Pause the tape again and have a look at B. So this is what I got here. My final answer came out to be n is equal to 25 over 2. And if I wanted to write that as a mixed number, 25 divided by 4 is 6, 1 remainder, so 6 1/4. Now what did I do here? Well, first up, you may notice that I changed the 2 3/8. I changed that to a mixed number. 2 times 8 is 16, plus 3 is 19 over 8. I also changed my 3/4, which is on the left-hand side here, to 6 over 8 because my denominator, common denominator, is going to be equal to 8. So I went through and I added 3 over 4 to both sides. And that gave me n over 2 by itself is equal to 19 over 6 plus the 3/4, 6 over 8, 25 over 8. So that was n divided by 2. I got rid of the division by 2 by multiplying by 2 on both sides, multiplying by 2 there. And that gave me 2 over 1. 2 times 25 is 50. 1 times 8, 50 over 8. Dividing the top and bottom by 2 gives me 25 over 4. That's fairly difficult, little tricky, isn't it? Now the next one here, you can use your calculator for, because we've got decimals here. So let's go through and do it. A divided by 2.8 minus 2.5 is equal to negative 3.7, like that. Now we'll begin here by going through and what are we going to do first? We'll add 2.5 and we'll add 2.5 to both sides. A divided by 2.8 is equal to, now, if you like, you can use mental math, but I'm going to get my calculator here and use that, and I encourage you to do the same. So On the right-hand side, I've got negative 3.7, and I've got plus 2.5. And that's equal to negative 1.2. So I've got a divided by 2.8 is equal to negative 1.2. Division by 2.8, I'm going to reverse that by just erase that part there. So multiplying by 2.8 and multiply the right-hand side by 2.8. And at the end of the day, we've got A is equal to negative 1.2. So negative 1.2 times 2.8, and that's equal to negative 3.36. So there's our solution there. So that was a nice straightforward one. All right, why don't you go through and stop the tape and try this one here. So this is what I got. I went through and I subtracted 3.3 from both sides to begin with, and that gave me the 1.8 minus the 3.3 gives us the negative 1.5. Division by 1.6, reversing that, multiplying by both sides by 1.6, and that leaves me with a single b there. Negative 1.5 times the 1.6 gives us that b is equal to negative 2.4. So here's the last one. Okay, example number 3, applying a two-step equation with decimals. Now look at this. We've got to come up with the equation here first of all. Colin has a long-distance plan that charges 5 cents per minute. So let's highlight some things here. 5 cents per minute for long-distance calls within Canada. There's also a monthly fee of $4.95. 1 month, Colin's long-distance charges came to $18.75. How many long-distance minutes did Colin make that month? Now, you know what I'm going to do here? I'm going to go through to start with, and I'm going to assign a variable. Now, we could use M for minutes. It doesn't really matter. I think I'm going to use an M. So I'm going to begin by let M equal the number of minutes. Now, what's the charge every minute? The charge every minute is 5 cents. However, we've also got a $4.95 and we've got an $18.75, don't we? So what we need to do, that 5 cents per minute, we need to change that into its decimal form in dollars, 0.05. Now, if we speak for M minutes, the charge for M minutes is going to be 0.05 times M. Okay, so the number of minutes M times 5 cents is giving us the total charge. Now, we've also got that pesky $4.95, and the total bill on the right-hand side of the equation comes to $18.75. So there's the equation that we have to solve. Now, I would like you to go through and try solving that. I'm going to pause the tape, and we'll come back in a moment and see how you made out. So, checking this out here, we began, and so the first thing I did was to go through and subtract $4.95. Okay, 18.75 minus the 4.95 gave us $13.80. Multiplication by 0.05, I divided both sides, and leaves us with a single M there. $13.80 divided by 0.05 gives us a total of 276 minutes. All right, we have a similar one here. So Colin wants to go over to a cheaper plan. So why don't we have a look at this one? And we'll come up with the equation first of all. So this time we've got 4 cents a minute, and the monthly fee is $3.95. And for how many minutes could he call long distance in a month for the same charge is $18.75. So what's our equation going to look like? Well, the right-hand side is going to be the same as before, $18.75. We'll use the same variable M. 0.04 is the cost per minute, 4 cents, times the number of minutes, plus the monthly charge, $3.95. So that's the equation you have to go through and solve. So pause the tape and see what you can come up with there. So there's the equation. I began by subtracting $3.95, and that gives me that. What's the next thing? Did you divide by 0.04? Divide by 0.04. That leaves us with a single M, $14.80. I'm going to grab my calculator for that. So 14.8, and we're dividing by 0.04, and that gives us, look at that, 370 minutes. Now, should Colin change his plan? Well, the first plan gave him 276 minutes for a total cost of $18.75, and guess what? On his new plan, lower rate, he gets 370 minutes. So what you're going to be doing on class the next day, you'll be working on these questions here.